Everyone, and welcome to today's webinar. My name is John Pitcher, and thanks for taking the time out of your busy schedule to join us for today's webinar. I'm here on behalf of VinZero, and here at VinZero, we're all about fostering innovation through delivering software and hardware solutions, consulting, training, development, and managed services. We've become a trusted technology advisor to our customers through the breadth and depth of our service, offering our technical expertise, our commercial flexibility, and high levels of customer service and understanding. Globally, with a total of 32 offices and over 550 employees around the world. We supply a range of different services and solutions to various aspects of the engineering and IT communities, including data management and integrated solutions, BIM implementation, consulting services, CAD management services, on-site and online training, and customized content creation. I'd like just to introduce myself before we get underway and launch into today's subject. So as I said, my name is John Pitcher. I'm working as a technical consultant in the manufacturing space for VinZero. And I started my career as a fitter and machinist and progressed into the CAM space in CNC design. I've been involved in numerous aspects of engineering, including hydraulics and pneumatics, machine tool and tool design and manufacture, CNC programming, as I said, and general heavy industry fitting and machining. I joined the Autodesk channel about 17 years ago and have been working as a trainer and tech engineer for various Autodesk applications during that time. I've also supported numerous 3D printing environments and worked in the additive manufacturing space for some time for previous companies as well. So with today's webinar, we're going to briefly consider a few areas of mechanical and electrical design and how you can leverage your existing 2D data and geometry that you may have been generating over the past years. You don't need me to tell you that there's a lot of time and effort and therefore expense that's tied up in those DWGs or 2D design geometry that you've maybe been creating over the years. Our teams here at VinZero, we talk to many customers, and in fact, you may be one of those customers, and these are some of the things we've heard from our customers. Will 3D help with product quality? Is this going to take a lot of training before everyone's up to speed? What happens to all of our current data that we've got in AutoCAD already? And will this improve our business? Will we win more business by having these design engineering tools available to us? I guess if you have these questions or similar questions, I hope that we can address them for you during today's webinar. So when we talk about mechanical engineering and electrical design and factory design fields, there's several workflows for working in both 2D and 3D models. We often talk about the Inventor software, which some of you may have access to and may have come across in your work environment. And today we'll be covering sort of three main themes, I guess, and moving 2D data that may be existing within your organization into a 3D world and linking some of that geometry. We can also utilize these together and work on a project concurrently. For example, if you're working on an electrical design and a factory layout, we can integrate those systems together and create a much more integrated workflow and a collaborative environment that helps us create a better end result within our system. So when we talk about creating 3D models from our 2D designs, and obviously, as I said before, many of us would have DWGs in our system that maybe date back 10, 20, 30 years. I know some people that have been using AutoCAD since the 80s when it was first conceptualized, and a lot of that data is still available and still being utilized within the various engineering aspects of their business. And so I guess the real question is, how hard is it to utilize some of that 2D geometry that we may have existing and convert that over to 3D design so we can create some further interactions and potentially improve our design process and ascertain better results as far as working with our engineering data is concerned. Interestingly, it's probably easier than you think. And if you haven't seen this previously or tried it, we'll be demonstrating shortly how we can work between AutoCAD and Inventor and how we can utilize some of that 2D geometry that we may already have. So we can obviously use our existing DWG files and convert those to 3D models. And one of the very powerful elements of this, in the last 6 or 8 releases of Inventor, there's been some developments in the interoperability and interaction of the DWG file to our 3D CAD model. So we'll be demonstrating that in a moment and look at how we can simply copy paste, for instance, from AutoCAD straight through to Inventor, and then how we can utilize that to perhaps create a full working assembly, do some clearance checks and things like that on our particular model as well. So there's a lot of different options and functionalities that we've got here, and a lot of benefits in working with associativities and keeping the interactions between that 2D geometry that we've already got and working through to convert some of that into a 3D type environment. So as far as working with the AutoCAD software, and many people would be aware, AutoCAD is one of the most widely used CAD systems throughout the world. And it's obviously been a tool of choice for many, many years. And we're still finding that lots and lots of companies are utilizing AutoCAD for various aspects of their business. And we're not saying that you should perhaps change that. In actual fact, you may have users that have been working with AutoCAD for 10, 20, 30 years, and they're very confident and happy using the AutoCAD software and generating what is needful for your business. So I guess the bottom line is, if you're comfortable with that scenario, don't change that. We're not necessarily here to change things in that sense, but how can we improve? How can we make this better? So yeah, like I said, you may have some people that are old school type drafters who have been using AutoCAD since the 80s or 90s, and they're working through there and creating some pretty amazing designs for you. No problem with keeping that going. But what we want to talk about today is how we can move that forward to be a more collaborative and working environment for us moving into perhaps a more 3D model space and world. Now, AutoCAD does have some very, very powerful tools, and for anybody that's using the AutoCAD electrical interface, you'd be very familiar with creating your schematics and various elements of equipment within your AutoCAD electrical space. And again, a very, very good scenario. However, the challenge with that is that it becomes almost islands of information. These are often called silos, and you've probably heard that expression before, where we have silos of information in a particular scenario. And I guess what we want to talk about today is a little bit about bringing those silos together in a more collaborative way and creating communications within your electrical environment that can then be linked into your 3D mechanical space, but perhaps even like a factory layout that has a bunch of electrical scenarios and designs within it. How can we utilize those links? So there's an amazing link, and I won't be going into this in huge detail. Electrical is actually not my field of choice, but the electromechanical link from AutoCAD Electrical to Inventor is an extremely powerful tool. We've got many customers using that for different design concepts, and obviously for ensuring cable lengths are correct and ensuring we've got the space to potentially fit cables through a certain area, which is detail that would be very challenging to get from an AutoCAD scenario. But within Inventor, it's a very, very quick and easy process. So there's a lot of different elements like that we can work through. And we'll certainly, as I said, I won't be able to demonstrate this one today, but we will play a short clip later on if we've got time to see how that functionality behaves. As far as factory layouts go, and for anybody that's done work in this space, obviously in the AutoCAD field and specifically AutoCAD architecture, some of you may have seen the asset library that's available there. Again, we've got very similar functionality in the Inventor space, but let's assume that maybe you've got a factory layout that's done 10 years ago in AutoCAD architecture. And what we can do is link that up, and I'll be taking you through, again, another little clip on this one. This is quite an involved process, but we can obviously link, and you might notice on the graphic at the top of the screen there, the third button in from the left, we've got this option to open a factory layout inside of Inventor and look at it as a full 3D model as such, where we can start doing things like, different types of studies. So we can do a time and motion studies. We can look at spaghetti mapping and some other, very powerful functionality that might be available to us within a 3D environment that we don't get in a simple 2D environment. So we'll perhaps go and have a bit of a look at that in a moment as well. So we can drill down quite a bit and have a much more in-depth look at the way our factory is going to behave, and potential bottlenecks and areas of challenge where maybe we need extra resources or conveyor systems that are going to help us with the smooth flow of product from the start of a particular manufacturing process to the end. So yeah, great to be able to do that. And obviously the other powerful thing that Inventor gives us is an automated bill of materials. We'll touch on this one a little later on as well, and look at some of the different functionalities in regard to that. But what we're going to do now is we're going to launch in and just take a look at some fairly basic functionality to start with, and working with a fairly standard sort of AutoCAD type design that we might have created, or a layout or something, and we're going to look at bringing that into Inventor and working with the various elements of that. So I'm sure many of you would be familiar with maybe a design that perhaps looks a little like this, where perhaps in AutoCAD we've got some sort of mechanical design, and we'll dig a little bit further into this one in a moment. But just to, I guess, start this sort of demonstration off, so we're going to, just looking at a fairly simple hydraulic-driven lever system. What I'd like to do to start with is show you 2 or 3 workflows where we can generate or take data from a 2D environment and plonk it straight into our Inventor interface and work with it and look at how that might behave as we move forward. So first up, like I said, very simple design here. We've got just a series of lines, circles, arcs, etc. Quite basically, when we have a design like this inside of Inventor, we can simply do a copy process. And I'll jump into my Inventor now. Most of you hopefully are a little bit familiar with the Inventor interface. So I'm working in Inventor 2023 today. This is the sort of current version, although 2024 will potentially be released within the next month or so. So there's a bit going on in that space. But effectively with that sketch that I've copied to my clipboard, if I was to go in and create a 2D sketch inside of Inventor, basically very similar tools to what you'd be used to with your standard AutoCAD system here of drawing lines, circles, and arcs. But what I can do here is simply go in and paste this particular geometry, which I've just pulled out of my AutoCAD scenario, and I can paste this straight into Inventor just with a single click. Okay, so the copy and paste, Control C, Control V for those of you that like hotkeys, really handy functionality to be able to use. Now, again, lines, circles, and arcs inside of Inventor. And look, we could go off and create a whole bunch of dimensions and things for this now. But what I thought we'd just do as a brief look at how we can perhaps utilize this geometry, incidentally, scales correctly. So we could obviously do a check measure in AutoCAD and look at the dimensions and physical sizes of this part. Obviously, they are consistent, as long as your model is drawn at 1-to-1 scale. Obviously, that would be a fairly typical type scenario, but yeah, certainly working with that is fairly standard. But what I really want to just talk about now is how we can utilize some of this information and start turning it into a fully working 3D model. Now, as far as Inventor's concerned, basically I'm going to move out of the sketch environment where we're going to now look at creating some solids, utilizing just our standard extrude features, etc. So we can just simply go and pick different geometry here and tell it the thickness that we might like here of those particular items. Now, once I do this, what Inventor does, because I've used the sketch, Inventor by default turns the sketch to invisible because I've utilized that. But quite easily, we can come back over here, turn the visibility back on, and we could go through now and start extruding the rest of this geometry quite quickly and easily. One thing I want to just talk about, and we do cover this in all of our training, but basically, we've created our first component here, or our first solid inside of this 3D model, and that's just simply called extrusion 1. Obviously, I can give that a new name, but let's say this particular part up here that I want to now extrude, this group of shapes up here. Now, what I'm going to do with this one is I'm actually going to use this functionality here where I can create a new solid body within my part file. Okay, so if I select this and I can give it a name, so let's call this top arm. Okay, and basically that becomes the second solid body. Actually, I will just do this little area here as well. And we're going to OK that. So utilizing this functionality here creates what we call a second solid body. So notice over in my browser here, I've got solid bodies, and at the moment we've got solid number 1, which is our first extrusion here. But if I OK this, notice what happens now. I end up with a second solid called top arm. Okay. Now, we could go through and extrude all these different components, and we could do some things like creating revolutions to create maybe our cylinder here. And we want to revolve this around this center axis. And what did I do there? Let me just do that again. Let's do that again. So revolve. Okay. So yeah, we're going to create this as a third body, and yeah, maybe we'll call this cylinder barrel, or whatever we want to call it. So as you can see now, we can populate our assembly very quickly, working through each of these solid geometries, and we could go through and revolve the various other elements of our assembly, etc., and create these as separate solid bodies. Okay, so we could work our way right through this assembly, and yeah, as I said, just simply creating extrusions of the various areas of our component, or whatever it might be that we're actually going to be working with in that sense. So very quick and easy to work through that particular functionality there. Now, with regard to working with this, so that's one way of importing 2D geometry into Inventor. Once we get to this point, I just close out of that. Sorry, let me jump back into Inventor. We can obviously assign materials and different things to this, but when we work with multi-body environment, like I've got here on screen, we've got an option up under our Manage tab here to make components. Now, basically what this does is, and I'll need to save my model first. I'll just simply save it as part 2. But effectively, what this allows me to do is from these solid bodies, I can go through and say, I want to create parts of each of these solids and convert them into separate assembly components. Okay, so we've got some, basically this step here is allowing me to make components from my solid body. So, and again, I'm just going to save a bit of time rather than going through this whole process. You can see here that we can, we're now creating these Inventor part files by working through this process. We've got some options here. We can scale this as we go through as well. So you've got a number of options there. We can mirror the part. There's a number of things there. But if we apply this, Inventor goes off and builds these 4 components and will create for me a new assembly file. So if I go down here, Inventor's created an assembly called part 2. And here's those components that I was working with previously and that I've created from that solid geometry. So some fairly powerful functionality available to us. The whole process of this is that we can take these items through and work with all of that geometry. Like you can see here now, I've got my 4 components included in my assembly. And like I said, if I'd spent the time to go back and work with this, obviously we could make a change to that. The other amazing thing about this is changes made in this environment. So if I was to change the length of this particular item here and update this assembly, as you can see, my assembly will change and update. And if I allow this to do its complete update, so we've now got our arm at 990 millimeters long, this is driving changes across to our assembly also. So you'll notice that my assembly is looking for an update. Up here, it's waiting. You can see the little lightning bolt by each of these components. If I select the local update, watch what happens to the length of this arm. So the actual part file is now driving or controlling my assembly. So this is a very, very powerful method of what we call top-down design, where a part file can drive changes into an assembly. So this is a really, really powerful tool, and it's something that we go into quite a bit of depth in our advanced assembly modeling class. For anybody that's been on that class, or if you're interested in knowing more about this, we do run that class on a sort of 6-weekly cycle. So if you'd like to learn more about multi-body modeling, which is a very, very powerful tool inside of Inventor, not something we've got time to go into in huge detail today, but I hope you can get the idea of what we're talking about here in controlling an assembly based on the actual geometrical changes from within the Inventor scenario. So that's one way of working with AutoCAD geometry inside of Inventor. Now, like I said, 2 or 3 other methods, and we're just going to briefly touch on a couple of others. Obviously now we've got interactions between Inventor and AutoCAD. So if I was to open a file from the AutoCAD DWG files range down here, I can look at the different files that I've got available to me and actually work with the Inventor files. Now, I'll just quickly check here. Okay. So when we open an AutoCAD DWG in Inventor, there's some other very powerful functionality that we've got here. There's a very interesting little button down here for options where we can either open the DWG or we can choose to import the DWG. Now, when we import the DWG, we get some very interesting functionality. And what this actually does, it links the DWG from AutoCAD with our file inside of Inventor. So a very, very powerful functionality. This has quite a lot of interoperability that does some, very, very interesting elements for us. What this does, it takes us through a wizard where we can go and have a look at the different areas of the way that this is going to behave. Basically, what this is doing at the present, it's looking at the DWG file and ascertaining what layers are available for me to import. Now, this is a very simple DWG file that doesn't have a huge number of layers, so this will happen fairly quickly. But basically, what we can do is actually map the layers from the AutoCAD DWG and bring them across into the Inventor space. Okay, now we've got a bunch of options here, but I'm going to jump through this and go to the next area where I can choose what it is that I'd like to import. So this wizard actually takes me through a sequence of events where we can bring in title blocks, borders, we can tell AutoCAD what we're actually trying to do here. And as I said before, we can map different things from the from the AutoCAD environment and promote them into the Inventor space. And look, a bunch of different tools here, depending on the type of file that you're bringing into Inventor, you get options to constrain all the endpoints. So we basically create, for those of you that are Inventor users, we can create effectively a bunch of mental blank coincident constraints at the endpoints of all of our geometry. We can also, if you've got parametric constraints from your AutoCAD environment, obviously this is now an option. We can obviously promote them across as well as part of that particular process. So what this process and this wizard actually does is it allows me to bring this in. The other cool thing you can do with this down here, we've got this option to save the configuration. And basically what that does is allows me to set up my preferences and my standards as to how I would like to see the different elements from AutoCAD translated into Inventor. And we can obviously reuse that configuration file for every time that we do this. So for those of you that are a little bit involved in the programming side of things, obviously we could automate a lot of this as well. So if you wanted to, if you've got batches and batches and piles of DWG data in your system, you could simply go and create the various configurations and tell Inventor how you would like that to work. Okay, so basically this will take us through and bring in my DWG here as a drawing by default is what I've got, but equally we can work with each of those different environments as we go through. Now another process, so that's a further one. I'm not going to go too much further into detail in that one, but the other thing that we can do here in a new part file as well, and this is very similar. Sorry, I'll just open another standard Inventor part. When we're inside of a 2D sketch in Inventor, you can also utilize a little button up here where we can simply insert an AutoCAD file directly into a 2D sketch. So again, a little bit like I did earlier with our copy paste, we can simply copy that across. Now, when you copy paste, obviously that doesn't create a link. That's just a simple copy process. However, this one will give us that option. Okay, so we can simply go in and pick up a DWG, take it through here, and that will allow us to work with that particular geometry. Okay, so we can link an AutoCAD file into a 2D Inventor sketch. Again, in the background at the moment, this is processing that data and looking at the the AutoCAD DWG for different properties and different elements of that nature. So yeah, basically we can go next here. Again, we get that same sort of process where we can set up our preferences, and yeah, we're able then just to work with that 2D AutoCAD geometry directly into an Inventor sketch by using the import AutoCAD function here that allows us to work with that geometry. So that's three ways, I suppose, of working with AutoCAD data. Now, I'm talking a fairly simple data set here. Obviously, you may have some much more involved areas of within, full factory layouts or whatever it might be. Again, working through different types of geometry in that sense is also a fairly versatile option for working with AutoCAD and Inventor interactively. So I hope that helps. Like I said, very, very easy to do. Create a quick test yourself. And look, if we had some more time today, we could perhaps dig down a little further. But something that I would encourage you to look at is that functionality that I used here for multi-body modeling, and then utilizing our solid bodies to create working assemblies using the Make Component option from our Manage tab here. Now, you can do these one by one as well, so we can obviously make a single part from that and work with there. One other little thing that I do find quite helpful inside of Inventor is we do have an option. For instance, if I wish to laser cut this particular component here, for instance, I can go in here and export this face by simply right-clicking. And for those of you that are familiar with the sheet metal space or working with laser cut and profile cut information, we can obviously export a profile directly from a face in Inventor as a DXF. So DXFs are commonly used in laser cut, water cut type machines, and we can certainly export straight from a face to be able to create that part as a flame cut or whatever it might be that we're going to use as part of our geometry for working with that particular model. Okay, so I see a question there. I believe you will receive a recording if you've attended this webinar, just to answer that question. So yes, I think you will receive a link to the recording of this webinar at the end of the webinar. So yes, just to answer that question. Incidentally, if you wish to pop other questions in the chat, we'll hopefully have some time at the end for Q&A. So yeah, if there is any questions, I'll stay online for a moment or two after the close of our webinar to hopefully answer any questions for you. Okay, so just back to our PowerPoint. So again, here's another classic example, and I'm sure those of you that have worked with AutoCAD before have come across a fairly traditional part that maybe looks like this, and you sort of look at it, and for those of you that have worked in 3D design or in an engineering type environment, probably look at that and are fairly quickly able to ascertain that this block of material, whatever it might be, has a series of holes through it and some cutouts on the corners. I guess that comes with time, doesn't it? Experience helps us to appreciate, I guess, what a 3D design or 3D component looks like. Again, I could simply copy and paste these views out of AutoCAD and place them into Inventor, as I showed you a short while ago, and effectively, and I did just quickly do similar to that earlier on. So when you look at this particular part, I'm sure those of you that have sort of worked in engineering have probably already created a mental picture of what this part looks like. But obviously, this is how the part might look in Inventor. And what I'd like to do now is just quickly show you how we move forward with this. So I guess, yeah, if we're looking at that particular part inside of AutoCAD, that would be a fairly typical view of that part. And what I'd like to do is just quickly show you as by way of live demonstration, how we can actually convert this part to a 2D drawing, but with some other beneficial factors. Now, one or two of the main things that you get from Inventor, obviously, because we're working with solid material, one or two things we can do is very quickly see where the center of gravity is in this particular part. So we can, quite easily ascertain where that is. Something else that we can obviously look to as well, if I've specified that this particular part is made from stainless steel, and if I was to go up here and look at the properties for this particular block of steel, obviously in this space, we've got a whole range of properties or metadata that lives with the file. Under here, though, we've got our physical options, and very quickly I can see that if I was to make this out of stainless steel, which has a density of 8 grams per cubic centimeter, the part would weigh 2.734 kilograms. There's the area, there's the volume, some moments of inertia, and again, the center of gravity in relation to the origin of the actual file. So these are all just standard properties that you get with your Inventor software because it's working with a solid. Now, if I went over and said, actually, I want to switch this out and see how much it will weigh if I make it out of titanium, here's my density. And you'll notice now, rather than weighing 2.7 kilograms, we've now got this part weighing 1.5 kilograms. So you can see there, very, very easy to do quick material studies. If we made it out of steel, much the same as stainless, slightly lighter than stainless, but and yeah, we can go through and make it out of sort of whatever we would like. As you can see there, obviously every material has a known density, and so we can work through and look at the different areas of that. And all those properties live with the particular model. So I'm going to revert this back to, let's go back and say, let's make it out of stainless steel again. And I'm going to apply that and close out of this, because what I'd like to do now is just take you through a very quick process of converting this solid part to a 2D drawing, and just, I guess, the workflow as to how we would do that. So a standard drawing in Inventor looks a bit like this. Basically, when we create a model of a particular part, we can simply pick up here to see which particular views we might like to have on our drawing sheet. Obviously, we can change our scale up here, make this a little larger. But effectively, within this situation, we can very quickly create our isometric views and decide to work with the different areas and elements of this. So if I would like to see my hidden lines, et cetera, what I'll actually do is also place an isometric view up here of our particular part. So again, when we go off to create that model, we can simply pick up like so. Now, very quick and easy, obviously. Again, similar views to what we showed you back in the AutoCAD side of things there. So we've got effectively these three views. Like I said, whoever created this file probably had to go and draw these views individually. The nice thing about Inventor is we're creating the view directly from the model, and one or two other things that I'll show you in a moment in relation to that. With this particular view here, I'm going to make this look a bit prettier. So I want to have a shaded view up there. And we've got some really clever tools for doing things like under our annotation space up here, we've got options to retrieve annotations for a particular part of our model. So what this will do is show me automated dimensions as to what I did. And I've immediately spotted here that I've actually opened an imperial drawing, so I apologize for that, but I'll quickly switch that out. So under here, I'll have a this is coming up from the standard ANSI. Let me apply this, and I believe this will. No, but anyway, we won't go into that in too much detail. But yeah, as I was saying, we can obviously pick up here all of our dimensions. And again, we've got some amazing tools here Obviously, these dimensions are not how I would like them displayed, but I'm going to pick all of the dimensions on this view here and tell Inventor to arrange them in a slightly better way. And these dimensions are all automated, if you like. And so as you can see here, we've got all of these dimensions. Now, the amazing thing about Inventor is that a change to any of these values, so if I was to select this particular value here, and what I'm going to do, I'm going to use a function here to edit the model dimension. And if I was to make this a 6mm hole, for instance, notice what happens. It'll update on all of my particular views here. So you can see that the hole now has changed back to 6mm, 0.24 of an inch for those of you that are wondering what the sizes are there. Again, I should have checked my template was actually a metric template. My bad on that front, but I think you get the idea. And effectively, if I was to go back to my block now, notice the holes here are no longer 10mm. So I can drive my solid shape sizes from my 2D drawing in Inventor. This is a really, really powerful functionality and something that's worth understanding properly. Obviously, we can create quite an interactive model in that sense, I guess, and certainly work with the different areas of modifying designs. So again, I think you'll agree that what I've created there in perhaps 2-3 minutes, compared to what whoever had to draw all these different lines and arcs and things in their AutoCAD, I think you'll agree that the time frame, and I've achieved a whole lot more. So the very powerful group of options there for working with that. And like I said, within Inventor, we get a full bomb view of the in actual fact, I'll just open up another file here just to quickly show you. I'll come back to that one in a moment. So effectively, the concept is, though, that we can work with all sorts of different information, and perhaps I'll jump into this one a little later on as we talk about those particular elements. But you'll notice down here we get some properties automatically populating through. If we had a field here called material, it would put in here that it was stainless steel, and we could pick up things like the mass and the volume and the weight automatically, because they are all metadata that lives with our Inventor solid shape. So I hope that helps. Like I said, quite a lot going on there, and probably covered that a little quickly, but anyway, let's jump back into a couple of other things. I do just want to briefly mention, and I'm just looking at the time, we probably need to keep moving along. So I'd like to just take you through one or two other little elements of the interactions from the AutoCAD space. Again, as things get more complex and more involved in AutoCAD, obviously it becomes harder to determine. And look, we could quickly go through and model that particular part by copying geometry and ignoring the dimensions or the hidden detail, etc., to create solid geometry from any of these particular items. All right, so here's a classic example of maybe a factory layout. So what we've got here, this is actually from the AutoCAD architecture software, which has a library and a palette of maybe, different conveyor systems and things that you might use. What I'd like to do is just play this through, noticing particularly that we've got some options up here, particularly inside of this open in Inventor, so we can link an existing factory layout in the later versions of AutoCAD. So I'm going to play this through. I hope this will play okay. Basically, this person is going through and setting up some particular parameters for different pieces of equipment that might be inserted or included into a factory layout. So these are just wrapping devices that that we can bring in. So effectively, we can take that into our AutoCAD functionality. But like I said, notice this button up here, Open in Inventor, where this particular user is going to take this factory. And like I said, once we've got this in Inventor with our various modules and elements, we can obviously then utilize a lot more of the 3D type environment for working with, some very, very powerful, as I said before, time and motion studies, looking at roadblocks or potential bottlenecks in your manufacturing process or whatever it might be. So we can start using this. And if you wish to take it to the next step with Navisworks or some of the other tools that are included in the Product Design Manufacturing Collection, there's a bunch of options for working with things like clash detections, and we can do that in Inventor as well. But look, we can obviously do walkthroughs in Navisworks. We can, look at product flows and simulate product flows, et cetera, et cetera. So quite an assortment of different options. And just these interoperability functionalities of working between AutoCAD and Inventor. I think you'll notice some really, really powerful tools. And at this point, we're really only talking about those two tools. If you do subscribe currently to the Product Design Manufacturing Collection, as you're probably aware, there's a whole bunch of other tools in there, 3D Studio Max, if you want to get involved in the rendering side of things. And if you want to create, animations that are sort of video realistic, we can obviously go and do that. Like I mentioned before, Navisworks, there's a bunch of other tools. Obviously, we've got all the different suites of AutoCAD included in the Product Design Manufacturing Collection also, where, AutoCAD Electrical, AutoCAD Mechanical, et cetera, are all tools that are available to us. Now, as I mentioned before, there's a bunch of options for, and again, I guess this drills in specifically to the Inventor space, where we can work with parameters to set up all sorts of different design interactions and things like clearances, or maybe we want to have a particular area within a model where we have to get a service technician in, so we need to know that space is available, so we can set up parameters within our Inventor scenario and utilizing this. So I'll just quickly switch back to Inventor, but whenever we create a model in Inventor, we get an area for our parameters where we can obviously come in here. Basically, this is a spreadsheet that lives in the back end of Inventor that's automatically generated by default. And each of these parameters are the sizes that we're working with. And we can mathematically link these. So you can use brackets, times, divide, all the BODMAS rules apply here for those of you that can remember back to your school maths days. But yeah, basically we can put Excel formula in this area here to drive linkages between perhaps the size of a hole and the distance it is from a chamfer, or whatever it is that you wish to convey as good design intent within your model. Really worth exploring this area. And again, we can set up tolerancing and all sorts of different options in this particular area as well. So this is tolerancing according to the 3D model. So if you do take your solid model straight out to a CNC machine, incidentally, we've got InventorCam included with the Product Design Manufacturing Collection, and we'll perhaps touch on that a little later. So we can create toolpaths ready for a CNC machine. We could send that straight off, and depending on how we've toleranced it, will be reflected in the actual the toolpath that we're using there, as far as working with that goes. Okay, so Inventor does have some very, very powerful back-end tools that are all sitting there working away and creating a lot of interactivity for us. Now, for those of you that have been using Inventor for some time, you may have come across the iLogic scenario where we can create rule-driven assemblies. And again, this is another extremely powerful part of Inventor that we don't have time to go into today, but maybe for another webinar another day, where we can use iLogic rules, basically like Visual Basic or programming code, to create variation within our assembly. So we don't have to create a conveyor that's 3 meters, 6 meters, and 12 meters. We can drive that particular rule and work with that. And Autodesk have also got a platform now called Forge, where we can actually promote this up to a website if we wish to sort of have a bunch of variations built into that as well. So very, very powerful tools. Look, iLogic is a very, very interesting and complex. Well, it's not complex, I suppose. It's simple if you know a little bit about programming. So it's it's quite a powerful tool for anybody that would like to explore how iLogic works in the Inventor system. And as I mentioned briefly there, we've got all sorts of tools for promoting our 3D models and our environments into other scenarios. So the Product Design Manufacturing Collection also includes a tool for doing nesting. So we can do nesting studies on our profile cuts. So if you want to lay them out on a 24 by 1200 sheet of 10 mil plate ready for cutting, or whatever it might be that you're doing, we can obviously do some studies there. We've got the simulation tools of Nastran and products like that included in the Product Design Manufacturing Collection as well. So some very, very powerful tools. We've got tolerance analysis, which we can go and do some studies on our model and look at how our particular components are going to interact, and if they're going to give us the correct clearance and give us the correct allowances for our model to react the way we want it to. So again, many, many tools included in the in the Inventor software. And like I said, there's so basically all of what you see on screen at the moment is can all be done inside of Inventor. No need to go off to another third-party app or anything like that. We can with InventorCam, it comes up as another tab inside of our Inventor model environment, where we can swing straight out and create CNC code, as I said earlier. If you want to do simulations, obviously we just launched the Nastran add-in, and all included inside of our Inventor interface. Okay, one or two other little things that I mentioned there. We talked about drawings. I think we've probably covered that enough, and the methodology for creating 2D and 2D outputs for our models, and adding different information to that and different areas of that. So I can see that our time's nearly gone there. So just really like to wrap up. And I guess the whole concept of today's webinar was to look at some ways of utilizing existing AutoCAD data and working with Inventor. As I showed, not difficult, very, very quick and easy. And like I said, the learning curve for the Inventor software is quite quick. It's we do obviously run training courses via Zoom at the moment, and certainly, if you're interested in going that path, we'd be more than happy and keen to talk to you about that. But effectively, we looked at converting 2D to 3D. We looked at some documentation with creating our design. Electromechanical, like I said, quite an involved process, but a very, very powerful process for linking AutoCAD electrical designs with your Inventor system. So you can do some, like I said, cable, understanding cable environments in the 3D space. We talked briefly about factory layouts as well, and hopefully you can see some benefits there of the 3D space. So there's a lot going on in the Inventor space, and I think you'll find as time goes on, there will be more interactions, like I said, through these other tools. And we've already got some great tools like CAM and nesting and different elements like that, working with that particular functionality. So yeah, like I said, the Product Design Manufacturing Collection, a massive swath of products that we can utilize and make use of to right across the manufacturing process, right from sales right through to the finality of that. So thank you very much for joining today's webinar. I hope you've enjoyed what we've presented. Thanks for those of you that have given us some feedback there already. I'm glad you enjoyed the presentation. I will just stay online for a couple of minutes. If there is any other questions, more than happy to try and answer those for you. One or two little things before we close off though. Please do go onto our events site. You'll notice we do run these type of webinars very frequently on different subjects. So anything from the architectural space to mechanical. We do have people doing these around the civil space and all sorts of different elements as well. So if you'd like to go to the link on your screen, you'll notice there will be a list of all the webinars that we have planned. We do run these quite frequently. And as I said, thank you very much for joining us. And if you'd like more information, please feel free to contact us at info@a2ktoechnologies.com.au. I would love to help you on your engineering journey and work through with you some of those different elements of mechanical design. So thanks again for attending. Have a great day and rest of the week, and we'll look forward to chatting potentially down the track.